This is the pattern number 1 in the UDF. So what I'm going to do is that I'm going to spin up the 5G Core SBA on the Kubernetes cluster, as well as I'm going to spin up the UPF at the Edge Cloud on another Kubernetes cluster, single node cluster. So once all those Kubernetes pods are up and running, what I'm going to do is that I'm going to run a G-Node-B simulator. This G-Node-B simulator will send a HTTP connections to the AMF for session. Then later on, I'm going to run another script to simulate N1 to create a sessions. Once the sessions established, or the PDU sessions established, the Ubuntu desktop here, which don't have a default gateway, I'm going to run the third script, which it will create a default gateway via the GTP tunnel to the UPF at the Edge Cloud. Then later on, I can get to the internet via the Free5gc net to the internet here. So this is the Cloud Native 5G Core baselines. This is a UDF. You can see that there's a Edge Kubernetes running here. There's a couple of Kubernetes nodes, and as well as this UE plus the G-Node-B. This is the Ubuntu desktop. This is the management jump host, as well as the Windows RDP. So what happened here is that I already pre-logged into the Windows jump host, 2 of the sessions, and as well as the Edge. So what I'm going to do is that I'm going to spin up the Edge UPF. So what you can do is that you can go to the Edge UPF and you can run a script called onboard Edge UPF. And I'm going to spin up as well as the 5G Core SBA, which is on the cloud. What you need to do, log in, and you can run the patterns on number 1. On a separate video, I'm going to show you how you can run the pattern number 2. So I'm going to spin up basically just a bash scripts to create all the ports, all the necessary port that required for the 5G SBA. While waiting for the port to spin up, let me show you quickly on this is a Ubuntu desktop. If I check, there's no default gateway. It's only have a local interface connected to the local network. So if you try to go to the internet, there's no gateway you can get to. Alright, so looks like all the ports are spun up and running. So what I'm going to quickly show you the logs, like for example the AMF. This is all the AMF that you can see from here. The other things that is quickly, I just want this is a log on the UPF at the Edge. When the SMF are started, what happened here is that SMF will negotiate with the Edge as part of the configurations to associate the PFCP request. 10.1.40.32 is actually the SPF, is the UPF at the Edge. Alright, so now what I'm going to do is that once all these things up and running, I'm going to create a subscriber. So that I'm going to use a Windows jump host, log into the web UI, and so currently there's no subscriber. What I'm going to do is that I'm going to create a new subscriber. So basically, all those are defaults perimeter. You don't need to change any of those because the configurations that I have created is all based on the default, including all the IMSI number, all the PLMN ID, and as well as all the network service slicing information. Those are all the parameters that you are able to modify if you need to. Currently, I have set up the N6 name as the DN network name as the internet. So what I'm going to do is that I'm going to submit. So now the subscriber are created. So what I'm going to do is that I'm going to try to simulate the connections. So as I mentioned, there are 3 scripts running here. 01 is basically to run as the G-Node-B simulations on the N2 interface. 02 is basically to run the UE on the N1, and the third one is actually to set up the default gateway on this box itself. Run 01. So it established HTTP connections to 10.1.10.30. This is basically the AMF. On a separate terminal, I'm going to run 02. So connection set up for PDU session 1 is successful. On the UPF, you can see that's the associations happening here, and you can see that's a tunnel interface on 10.88.01. 10.88.0/16 is my UE subnet. If I look IP A, you can see that there's a UE SIM tunnel 0. So what I'm going to do is that I'm going to run a 03. Basically 03 means that you just set that as a default gateway. 03. Alright, so now if I try to ping www.f5.com, you can see that I can get to the internet from a box that don't have internet access via the UPF, or you can 8888. Alright, so I have a browser here, so if I can try from the browser f5.com, you can see I can get to the internet, or if I want to go to the YouTube, do a streaming, I can get to that as well. The other thing is that if you want to confirm to make sure that your traffic actually traverses the UPF on the edge, this is the edge. What I'm going to do is that there's a sidecar port called TCP dump. If I jump onto the shell, if I run a TCP dump -nni any ICMP, I can run a ping www.f5.com. You can see that it's actually 1088.01. Let me Control C. 1088.01 is actually going to the F5 networks via this UPF. The other things that I want to quickly show you here is that I have, as mentioned, that I have some application deployed at the edge cloud. So what I'm going to do is that I'm going to use my my phone, which is the simulations phone here, the browser, to access to these applications rather than go all the way to the internet. So currently at the edge, there's a couple of apps that I have deployed. For example, OpenSpeed is one of it. Maybe I get -OY. I believe get SC. I have a games apps called Wild West, which I have installed here as a node port on port 31225. So what I can do is that I can try to run HTTP 10.11.10, which is the edge, and then the node port is 31225. Oops. 10.11.10.31225. So this is actually the applications that currently running on the edge, not on the internet. This is just a simple games that you can basically you can shoot. It's a shooting game. You can shoot the port that and bring the port down. But currently just a simulations of a game. The other applications that I have put here is which is also deployed at the edge is the port OpenSpeed test. If I jump onto this port IP address 74.116, I can actually run some speed test 10.233 116.80.80. So I can run a speed test. You can do a comparisons where from the client here, you're actually doing a speed test to the port within the edge. Of course, this is closer to the phone compared to if you run it via the CGN to the internet on another open speed test. So you can see that when the applications are closer to the edge, to the user, you get a high performance. What else? The other thing is that you can see the real-time status as well. Currently you can see that it is connected. If I show the info, it shows you the information on the AMF information, so your SUPI information, the DNN as I mentioned. This is the internet DNN that I have created, and this is the SMF information on the PD address that the clients are getting here. Alright, I think pretty much that's it. Thank you for watching.